Okay, we can start. Right. So good morning, everyone. Today we'll be discussing a very important topic when it comes to Python, which is going to be data visualization. So as you know, like if we get some sort of a data set, right? We can say some sort of something that is very raw, that doesn't have any meaning. We can do some analysis, right? We can look for relationships. We can check, we can draw graphs. And at the end of the day, from those graphical representations or from that analysis, we get meaningful information to decision making, for decision making, right? So same story to when we have some sort of a data set or some sort of data, they don't mean anything if you don't do any analysis, right? You have to analyze it. You have to find relationships. And once you find those relationships, those data will mean something, right? So that making nothing into something can be achieved using different tools, different methods. And one of the tools or one of the methods people use is using Python and mainly using Python visualization, right? So this is a very powerful tool when it comes to analyzing data and finding out relationships. So I think this specific part can be very useful for you throughout your 4 years, right? Even in your final year project, right? Because, and maybe in your other subjects as well, because this is a very easy and a very nice way to visualize things, right? Graphs, plots. The sky is the limit when it comes to Python, but this is a very nice thing that you can do when it comes to the programming language, right? So let's move to the lesson then. So if I'm not audible or if my voice is not clear, please use the chat or you can unmute your mic and let me know. And if you have any questions throughout the lecture, please feel free to use the chat or unmute your mic. Please, okay. So today's learning outcome is going to be use Python to produce easy to understand and convincing visualizations that can be used for presentations and during meetings. So basically, we use Python as a visualization tool. That is the learning outcome today. Right. So now first let's talk about charts and graphs in Python. So in Python, at the end of the day, you have to remember this as well. I think I did an activity on this. If you want any of these graphs, these are not by default enabled in Python, or these are not by default available on Python. So you have to install these libraries, right? Using the PIP. But once you install it, you have these types of graphs like pie charts, bar charts, box plots, histograms, line graphs, scatter plots, density plots, right? Box violin plots, heat maps, right? All sorts of graphs can be generated using these libraries once you install the library, right? So you have to remember in an exam, if we ask you to draw these graphs, plot these graphs, first thing first, what you have to do is you have to install the library, right? So you have to remember none of the codes that we will talk today will work without the library, right? So the most important thing is you have to install the library. What is a library? Library is like some additional set of tools that you can get to a programming language, right? So by default, those things will not be there because not all the people will use it. That's the thing. Why it is not enabled default in the programming languages? Because like whoever using Python, we can't guarantee they will use it. This charts and graphs, everything. So these are for specific set of people that use Python programming language as a visualization platform. So because of that, if you need it, you have to install it. Right? They are not built in. That's the idea. Right. So these are the libraries and modules that available when it comes to Python, and the description of each library. So you can simply Google search Pandas library or NumPy library likewise, then you can see how to import these libraries to Python. So these are very popular libraries. I prefer if you can get familiar with these names, because if you are working with Python, these names will pop up here and there most of the time, right? So the first one is Pandas. So Pandas is an open source software library providing high performance, easy to use data structures and data analysis tools for the Python programming language. So this is an open source library. That means you don't have to pay a single dime to have this. This is free, and this is a easy to use data structures and data analysis tools. So basically, you can analyze data using Pandas. And then you have something called NumPy. Is the fundamental package for scientific computing with Python, providing multi-dimensional array object, various derived objects such as masked arrays and matrices. I think in the last day we talked about these matrices and multi-dimensional arrays, right? So to use these multi-dimensional arrays and like efficiently, you need to have NumPy. Then you have Matplotlib. Is a Python 2D plotting library. So this is the library that we are going to use to plot most of the graphs that we are going to plot today, right? Matplotlib. And then we have matplotlib.pyplot. That is basically like another module within Matplotlib. It's a state-based interface to Matplotlib. It provides MATLAB-like plotting. I'm not sure whether you guys are familiar with the software or like a tool called MATLAB. It is very similar to that, but we are not going to use it today. Then Seaborn is a Python data visualization library based on Matplotlib. So either you can use Seaborn or Matplot. You have other options. And then there's another one called Plotty. Is another open source graphing library, makes interactive graphs online. And then there's another one called Bokeh. Is a Python-based interactive visualization library that targets web browsers to represent very large and streaming datasets. So if we have like a real-time dataset, you can use Bokeh as well. So anyways, there are lots of other visualization libraries, other libraries that gives different types of features. These are few, right? These are few that you can use. And in this module, since we are mainly focusing on introductory things, I'll be only working with Matplotlib. And for the exams, you will only be evaluated using Matplotlib. Okay. But knowing there are other options you have is good. And maybe in the project that you have to present, you can use other options, right? You have Plotty, you have Seaborn, you have Bokeh. So if you are interested in these libraries, yes, you can use these libraries in your project, that the Python project, the group project that you are doing. So if you're using these libraries, definitely you can achieve good marks, because you have to do a self-study, right? So let's cover up chart by chart, right? Let's discuss each chart and let's do a small example so we can get familiar with it, right? So the first thing first, the simplest chart of them all, the pie chart, right? So Python programming language has numerous libraries to create charts and graphs, as we saw in the previous slide. A pie chart is a representation of values as slices of a circle with different colors. I think you all have definitely seen a pie chart. So the slices are labeled and the numbers corresponding to each slice is also represented in the chart. In Python, the pie chart is created using the pie open bracket, close bracket. So whenever you see an open bracket, close brackets, this is a function, right? So function is like a something that is trained to do some sort of a task. So we don't have to worry about it. Whenever we call this function will take care of building the chart for you, right? So in Matplotlib, you have this function already defined and developed. Whenever you want to use it, the only thing you have to do is you have to call the function, like phi. When you say phi, then that function will be called and the graph will be drawn in your desktop if you use it properly, right? Which takes positive numbers as a vector input. So in this phi function, you have to give an input inside here. That input is going to be a positive numbers as a vector input. So you have to give a positive numbers. That is the idea, right? Then the additional parameters are used to control labels, color, title, etc. So if you want to give different colors, then there are additional parameters that you can pass inside this function where it will change the colors. So that is the idea of the function, right? So let's move to the next slide. Right, so this is a very simple example. Let's try to code this as well. So import matplotlib.pyplot, so Python plot as PLT. So whenever you want to use this, you have to call it using this name, because for this entire thing, you are going to give one reference name as PLT. So whenever you say PLT, that means you're calling this entire library, because otherwise you'll have to write this again and again and again. The best thing is you're going to say, okay, I'm going to import this specific library as PLT. Instead of PLT, you can say X. It doesn't matter. You can give whatever the name. It's like a variable name now. So whenever you want to call this library or whatever these functions, then you are going to say just PLT, right? And same story, import NumPy as NP. So whenever you want to talk with NumPy, you're only going to say NP. So NP, that's it. So it's like we are giving like a small name to address this entire library. You can give X and Y, that is also fine. It also works. That is the idea, right? Then you're going to say Y equals np.array. So you're going to use NumPy, and using NumPy, you make array. These are the array. Inside the array, you have 35, 25, 25, 15. So the sum of all these values, you can see the sum is going to be 100. Right? So this is out of 100. Then the labels, you have to separately define for the array. So 35 means apples, 25 means banana, 25 means cherry, 15 means dates. So basically, I made two arrays, that means, right? One array with the name Y or variable name Y using NumPy array function. And this is the array. And then you have the labels, apples, bananas, cherries, and dates. Then when you call the py function, you are going to say PLT. PLT is the library. So PLT dot, then you are going to say the function py. Then you are going to say Y, comma, labels. Y is the first array. That means this array will be passed. And then you have to mention the labels. So when you are passing parameters, the first thing that you have to pass is the actual numerical values. So the numerical values are saved in the array Y. And then you have to pass the specific labels. That means this. Right? So let's try to do this in Jupyter Notebook. Give me 1 second. Let me share Jupyter Notebook with you. I think you can see my screen. I'm going to type Jupyter Notebook. Yes, it's working. Okay, I think you all can see my desktop. I shared the Jupyter Notebook. If you can't see, please let me know. Right, anyways. So what I'm going to do is I'm going to go to desktop. On the desktop, I'll be creating a new notebook. I'll give it a name saying charts or something like that. So I'll say it's charts or graphs, or I can say visualization. I'll just give a simple name, charts. Right. So I renamed it. Now I have my notebook with me. Okay. So let's do this. So this is the code that we are playing with, import matplotlib. So let's try to do this now. Right. So the first thing, we have to import our library. So I'm going to say import matplotlib. So if I don't have this already, they'll give me an error, right? Let's see. Because this library is not a built-in library. So because of that, if I don't have this, they'll give me an error. But as I remember, in the last week, I demonstrated something using graphs. So because of that, I installed this in my laptop. We'll see, right? We'll see. So first of all, let me run this and see what happens. Yes, no module name matplotlib. So that means I don't have this module with me, right? That's the reason that I'm getting this error. No module here, no module name matplotlib. So how can we install this? Anyone remember? Anyone remember how to install this module since it is not there? Anyone remember? Right. So it's very simple, right? What we have to do is we have to run this command before getting this library. So you're going to say pip, which is the Python package manager, install matplotlib. First, you have to install the matplotlib. Then you can use it. So now you can see it will take some time to execute this command because now we have to install this. Okay, I have done a syntax error. They're saying there's no module name because it is MAR, should be MAT. Let me say MAT. Okay, I did a small spelling mistake there. Now I'm going to run it again. We'll see whether we'll manage to install it. Yes, I will. How about now? Can you see? Right. So now I'm getting, when I run this command, if you haven't run this command before, this command, this specific line will install matplotlib, right? But now you can see when I run this, I got this output, requirement already satisfied. Matplotlib in C uses my name and location. That means I already have matplotlib in my computer, right? See, requirement already satisfied. That means basically this matplotlib library is already there. Then I might have done some sort of a spelling mistake when I was importing the library. So I don't need to run this. But if you don't have matplotlib, this is the command that you have to write or you have to execute, right? Before doing anything. So I'm going to remove this so I don't have to worry about this. Let me check my spelling. Yes, there's a spelling error. It should be matplotlib. Now it should work, right? Let's run this now. Let's run this. Let's see. Yeah, no problems at all. Nothing happened. So that means my program is working. I don't have to worry, right? So next thing, you can run the next one in a separate column or you can keep it in this column. I don't mind. But now I'm going to create the new array. So I'm going to say y equals np array. Then what I'm going to do is I'm going to create an array with some information or some data. So I'm going to say 35, 25, 25, 15. Right? I'll zoom it a little bit more so you can see it clearly. Then I have to create the labels as well, right? So labels equals, inside the labels, I'll be giving fruit names, right? So I'm going to say apples, bananas, you can say bananas, and then cherries, and also dates, right? Good, right. Then I'm going to ask the library. So whenever I want to ask something from this matplotlib.py plot, I don't have to say this full name. I can simply call PLT, because PLT means this library, because I gave this library a simple name called PLT. So I'm going to say PLT. What I want is a pi. So pi. And then I'm going to pass my parameters. First, I have to pass the actual value. So I'm going to say pi. And then I'm going to pass the labels. Right. So just by passing, you'll never get this, right? Remember that as well. Just by passing, you will never get the output. You have to ask them to show. So I'm going to say plt dot legend and plt dot show. I think you can figure out what this plt dot show means, right? Because it just shows the graph that we develop. What does this plt dot legend does? That is the problem. This is new. So let's see what is it. What does it do? So PLT legend function is to create a legend for our pilot, which helps to identify and differentiates between different elements like lines, markers, or patches in the visualization. So basically, it helps to identify and differentiate between different elements like lines, markers, or patches in the visualizations, right? So let's see what it does. So let me run this. Okay, it looks a very nice chart. Nice. So let's remove this first. What happens? You can see what happens, right? I think you can see what happened. So when you run this legend, what you can see is, see, this square appears. This explains this. You can see here. Identify and differentiate between different elements. So it differentiates. This is apple. This is bananas. It differentiates every color using this legend. That is the idea. So you can see it's very simple, right? Like lines, markers, or patches in the visualization. So it just explains the visualization for you, right? You can remove this if you want. You can remove this if you want. And someone can ask the question, right? So this is simply an array. So why do we have to use NumPy for the array? Can we just use the array like this? Can we just create the array like this? Simply the way we learned in our lectures. Can we do that as well? Right? You can ask that question. Yes, you can. Definitely you can. But I wanted to use NumPy. So because of that, I use NumPy as an array. Because it is a vector array. So you have to make sure it is numbers. So that's why we use NumPy. Because the requirement is you have to input a vector array. But if you just simply input an array, the same thing will work. So that means if you remove this part, if you remove this and this, still it will work. Because at the end of the day, array is an array. So it's not going to change anything. So that's not going to be a problem, right? So this is very simple. Can you all try this, please? Because I want you all to try this. Can you please quickly try this if you have your laptops on? Because this is very important, because you are going to get evaluated with this. Quickly try to run this command, and if you face any issues, can you please let me know in the chat? I'll give you like 2 minutes. I'll give you the code as well. I'll give you the code. Otherwise, you have to type it, no? I'll give you the code in the chat. So simply you can copy and paste it there and see whether it's working. Here you go. I think I shared it. Let me share it again. Here's the code. And here's the import part. Right. Quickly try this. I'll give you like 2 minutes. It doesn't take that much time to copy and paste. Okay, enough time, right? So the next thing, let's do something, right? So these colors are auto-generated. What I want to do is I want to use different colors. So if I want to do that, you can again define the colors in a separate array, and then you can basically change the colors. It's very simple. Let me show you. So let's say I'm going to say colors, and then I'm going to say, in Python, you can simply give the names of the colors. So you can say black, and let's say red, and then we can say yellow, and then we can say green, something like that, right? Green. How many fruits we have? We have 4 fruits, so we need to have 4 colors. So let's run this now, the program. So I'm going to go to the top. Nothing happened because I didn't pass this array inside the function. So when you're plotting the graph, you have to mention the colors as well. So I'm going to put another comma, and I'm going to say colors equals colors. So in this, in case, I'll just change this to my colors or something. Otherwise, you are going to get confused with what is this color. So the colors means it is a part of the function. So I'm going to say this colors equals whatever the colors I define. So I'm going to say my colors, right? And then I'm going to run it. Now you can see the colors are different because I defined the colors, right? I say black for apples, red for bananas, and yellow for cherries, and green for dates. Likewise, now the colors have changed. So this is very simple, right? The idea is very simple and very easy to use as well. As long as you know what parameters you have to pass, you are good to go, right? So you can try this out. You can try this same command. Basically, you have to add this part, then you can get a bunch of different colors, right? So it's very easy. That's what I want to say. Like, it's very easy to change colors, likewise, right? And also remember, whenever we draw the graph, this is the starting point. So the graph will start plotting from here, right? So the starting point is, this is the 0 degree, and like that we'll go 360 degrees around it. So this is the starting point, right? So that's why it started like this, okay? Okay. So now you can ask the question, can we change the like the starting angle? Basically, like if you want to start from 90 degrees, can you do that? Yes, you can. That is another parameter that you have to pass. Then you have to put another comma, and you have to say start angle, and you have to say 90. So if you say 90, then it will start drawing from the 90 degrees. You can see now the graph is different. Started from the 90 means here, right? It starts like this. So if you draw the graph, if you get the graph, you can see this in the W3 school as well. If you just search pie chart, you can simply see this. So if this is the graph, this is 0, this is 90, this is 180. It goes anti-clockwise, and this is 270. So when you say start is 90, basically it will start drawing from here on. So the starting point is here, right? That's how it works. And then it will start dates, then cherries, then bananas, and then apples. It goes like this. Right? So that's the idea. So there's a question recorded. I'm not sure about the recording. I have to check. I am recording this, but I can't guarantee that I will upload this, because I have to check whether it's you have to get permission for that. I'm not sure, but I'm just in case, I'm just recording it. Okay. Then again, if I say 180, then it will start drawing from the 180. That means it will start, dates will start from here. Here you have the 180. So you can see now the dates are starting from here. Right. So this is how it works, right? This is how the chart works. you can test it out. I mean, you can test it out with different things, and you can see when you change the angle, the legend, that box that you use, it also moves, right? It also moves as well. So you can see that happening here, right? So these are few things you can do, and this is about the Python charts, basically pie charts, right? So let me share the slides again. There are some questions. I will answer those questions after the lecture, okay? Those questions are not that relevant to the lesson that we are teaching today. I will answer them after finishing the session. Otherwise, the recording is going to be here and there. That's fine. Yes, so this is how it's going to look. And this is example with colors. You can see there are some predefined colors. So you can say black. And if you just say B, then Python is going to assume it is blue, right? Or you can use hexadecimal codes, because in most of the cases, you can define colors using hex codes. You can do a Google search on this actually. It's very popular. You can use hexadecimal codes for colors. So you can just search hex codes for colors, and you can select whatever the color you want. So let's say hex codes, and you can go to this color picker. And there are very different colors, right? Like very unique colors. So you can select a very unique color from here, like something like this. And this is the hex code. So you can copy this hex code and go to your Python program. Instead of saying green, what you can do is you have to put a hashtag, and you're going to say, paste this hex code, the code that we saw. And this color will be there for dates. Now, if you run this, you can see this is the color that we saw, right? So you can use hex codes as well if you want when it comes to the color picking. Right. So this is an example with colors. So you can use hexadecimal color values, any of the 140 supported color names. So there are some 140 supported color names, like R for red, G for green, B for blue, C for cyan, likewise. So if you want to like use those supported colors, you can simply type the letter respective to each color, then you can simplify it as well, like in the previous example. So you can see in here, it just says B. So B is for blue. So you can see here, the blue color is there for cherries. So those are supported colors. So for those kind of colors, you can simply type B, then it will work. Right. The next type of chart is bar chart, right? So in your the project, we prefer that if you can integrate these things, then it will look so much better, because you can get some inputs from the user depending on your application, and then you can plot some graphs as well, right? You can do that. Right. Anyways, so a bar chart represents data in a rectangular bars with length of the bar proportional to the value of the variable. So Python uses the function bar, just like we use the function PIE, pi, to create pie charts. In this case, what we are going to do is we are going to use a function called bar to create bar charts. And yes, of course, we'll have to pass different parameters inside this bar function to get the proper value. So inside here, we have to write different kind of things. We have to pass different kind of values to get the bar chart, right? Yes, I can. Do you want the lecture note now? Do you want me to upload it now? Or after the lecture? Please let me know. If you want the lecture note now, I can upload it now. If it is okay to give it after the lecture, then I'll give it after the lecture. Okay, I will upload it now. Yes, sure. Give me 1 second there. Right. So this is the function as I told you. And in bar chart, each of the bars can be given different colors as well. Just like we did before, you can do the same thing. You can define colors, you can play around with it. Right. So this is a simple example for a bar chart. You can see import matplotlib as usual. And now what we have is a array, but it is not vector array. In this case, it is a string array. Under there, we have a vector array 38110. So let's see how to draw this graph in our what we call the Jupyter notebook, right? So the first two lines, we don't have to run it because we already have imported the matplotlib and the numpy. So I'm not going to import it again. But simply what I'm going to do is I'm going to say x equals np numpy array. That is going to be A, B, C, D, right? And then y equals numpy dot array. Again, I'm going to create an array, which is going to be numerical values. So I'm going to say 3, 8, 1, 10, right? Then I'm going to say plot dot bar. I want a bar chart. Then for the bar chart, I have to give the x coordinates and the y coordinates. What is going to be the x-axis? What is going to be the y-axis? Then I'm going to say plot dot show. Right. So shall we run this now? Let me run this. Okay, this looks good. You can see. So you can see the maximum value out from this array is 10. Right? This is the maximum value. So because of that, we have max up to 10. And the minimum value is 3. So you can say this is 3, B, C, D. That's it. Right? It is very simple. Because it's at the end of the day, it's a simple comparison. Right? So what happens if you put this plot.legend here as well? Right? What will happen? Will it work? Will it give an error? Right? That is the next question. Let's see. Why not? So you can see the plot.legend doesn't work for everything, right? That is the next important thing that you need to understand. Even though, let me run it one more time. There is an error. You can see this PLT legend whose label start with underscore dot is called no argument. So you can see this is not working. So that means like some of the functions will only work for some of the charts and it will not work for other charts. Okay, so it worked for pie charts but didn't work for bar charts. You can see. So this is how you draw a bar chart as well. And also, if you want this chart to be horizontal, right? Then you have to say not BAR, you have to say BARH. When you say BARH, that means bar horizontal. You can see now it is not BAR, it is BARH. So if I say BARH and run this program, you will see the bar is going to be in the other direction, right? So that's how you do it. That's how you can do it. I hope you got the idea. Let's see whether we can change the colors as well. Let's try to copy the colors from the previous example and try to do the same thing. I can't guarantee this will work because I didn't test it out, but we can try, right? It's not going to hurt to try. So we pass X, Y, and also my colors as well. We'll see what will happen. Okay, so it's not going to work like that, right? It is not going to work like that. So how can we change the colors now? So let me remove this part. Let's see. Why not? This should work. For some reason, it didn't. I just went to the documentation, to the website and checked how to define colors. This is the way we have to do it. Let me see. Give me 1 second. Right. So what we can do is this. We can't use different colors for different bars. But what we can do is we can use a single color for all the bars. Because what I can do is I can just simply say something like this. Let me show you. Remove this one entirely. I'll keep this hexa code for me. So I'm going to copy this and remove everything else. Right? Then I'm going to say here, just like I did before, colors or color equal that hexa code. I copied the entire thing. I'll write a random hexa code. I'm not sure what color this will produce, but I'm going to use it, okay? Let's see. So you just tell the color like that, okay? And it's supposed to work. So let me see whether it will work. After checking, I'll explain. Yes, now it is purple. Right? So basically, you can change the color of the bars. What you have to do is you have to give the x-axis, you have to give the y-axis, and then you give the color, and you give the color of the bar. Then that specific color will work. So if you say R, where R is going to be a predefined color, which is going to be red. If I say R, and it will become red. That's how it works. The idea is very simple. Right. If you have any questions, please let me know. And I will copy this code so you can also try. I'm going to copy the code that I executed here in the chat. You can give it a try as well. I'll give you like 2 minutes. Try to work with this. Run this in your computer. Only 2 minutes. I guess it's enough time. Very good question. Why we can't use different colors for bars? The thing is, since it's a comparison between the height of the bars, right? It's not that necessary. I'm not sure whether you're getting what I'm saying. Because in here, the comparison is the sizes of the pie, right? The sizes of the small pieces. So the pieces should have different colors. It is a requirement. It is a must. Like the pieces should have different colors because we are comparing the sizes of each piece. You check the right? But in a bar, what you're actually comparing is not the each piece, just the height, right? The height is the only thing that differentiate each other, right? So because of that, with this way, you can only change it to one color. But what I think what you are asking is whether it's possible or not, right? Say different colors for different bars. It should be possible. I'm not sure why it is not working though. Let's try it one more time. Okay, let's try it one more time. So one of your batchmates asked the question why we can't use different colors for different bars. I mean, first of all, it's not going to be that necessary, but that's not the excuse. No, we should be able to use different colors. Let's try. Let's give it a shot. Let me paste this one. So this is the same idea. So now you can see you can do it. Got it? It should be able to. See, now it is working. Previous one, I probably might have done something wrong. Did I answer your question, Puta? Or do it? BM 2023-102. Now it's different colors. Yeah. In most of the cases, this is not necessary. But if it is like an election poll or something, I'm sure you all have seen it, like during the Chanda season, like different parties have different colors. So it's not just the bar chart, they'll use the colors of the party as well. So yes, you should be able to do it, and that is a good question. So yes, you can. Of course you can. Of course you can. If you only define a single color, if you say my colors equals red, then it will become just red. But if you want to use different colors, then you have to create an array called my colors. And in here, you have to define the colors, and then you should be able to do it. Yes, of course. Right. So I will keep this. And then let's move to the next one. Because it's been an hour, so we have another hour. So the time's moving very fast. So yes, as I told you, if you want to make a horizontal bar chart, the idea is very simple. You're going to say plt.barh. So the H is for horizontal, right? H is for horizontal. And then you can ask, do we have to put a V for vertical? No, because by default it is vertical. So you don't have to worry about it. Yes, so this is how it looks like. Right. The next thing, the histograms. So the histogram represent the frequencies of values of a variable bucketed into ranges. Histogram is similar to bar chart, but the difference is it groups the values into continuous ranges. Each bar in histogram represents the height of the number of value representing that range. To make a histogram, the function is HIST, so hist, right? Hist. So inside this function, we will pass different values as usual. Okay. So when you plot the graph inside this function, we have to put our values. So I think now it's pretty obvious to you whenever you use this function to build a graph, we have a function with a separate name, and to that function we pass the values. There's a pattern, right? For all the previous bars or graphs that we use. For pie chart, the same story. There was a function called pi, and inside the pi, we send the values. Then we had a bar chart. For that, we had a function called, I think, bar, right? So in that one, we basically pass the values inside there, right? Then if it is horizontal, the function name changed to barh, but inside here we pass the values. So this is the pattern. So whenever you want to use some sort of a visualization, first you have to figure out the function, and then you have to pass out the values inside the function. That's it. So this function takes a vector as an input and uses some more parameters to plot histograms. So let's see how it works. I think I think you guys covered histograms in your O level mathematics. Did you guys did it? I think you did. I don't remember the exact name for it in Sinhala. I think it's Sankhya Bahuvashtra or something. I'm not sure. Can someone confirm me? Have you? I think you have done something similar to this. Can you? I'll show you a histogram. I think you have done something like this in maths. Then you had to like do this as well. Like you had to uh, connect these dots in O-level maths, as I remember. Now it's been a long time for me, but I remember we did something like this. I'm not sure whether you guys remember. Right? So this was there. This is not something very new to you, right? You know what a histogram is. Okay, anyways. So let's try to plot a histogram. Ah, very good. Okay, you have done it in your stat lecture as well. Okay, that's better. That's good. So you don't have to go that far then. Then you have done it in this semester. That's good. Right. So then you know why we need a histogram, what we can do with it. So I'm not going to cover those things. Let's move to plotting a histogram, right? So to plot a histogram, this is how we do it. So first you have to create that array. So let me, so there's few things that you might be not familiar. There's something called x equals np random dot normal, right? So this might be a bit upsetting, right? What is this random dot normal? Don't worry. I'll explain it to you. So before explaining anything, let's just try to copy and paste this command, okay? So I will keep all the things I'm doing and I'm going to go to a new one like this. Then I will type it here. I don't have to import anything because everything's imported in the first cell. So I'm going to say x equals np dot random dot normal. Then I'm going to say 170, 10, 250. Then I'm going to say plot the histogram x and then plot dot show, right? Whenever you call this plot dot show, it will show the histogram. So let me run this. Why they're not letting me go down? Yeah. Okay, I hope you can see it. Okay, can someone guess what does this random dot normal do? Can someone guess it? Guess this, looking at the output. So when you want to draw a histogram, okay, what you have to use is something called the normal distribution. Let me share the slides to you, the W3 school page to you. Then you can figure things out with this. And also I'll like clearly mention something to you, okay? This is very important. When you are learning a programming language, right? You can't learn the language just by attending a lecture. It's like learning an actual human language. If you're learning Sinhala, you can't just learn Sinhala by going to a Sinhala class, right? Because there are some words that you're going to learn by yourself. Like whatever the words that you know, you maybe learn some words from social media, some words from your parents, some words from your teachers, some words from your classmates, some words from your Sinhala class. Likewise, you have learned a lot of things when you're using a language, if it is Sinhala, right? So you can see the things you learn in Sinhala class and everything else. If you check the ratio, You have learned a lot from everything else, not from the Sinhala class. Sinhala class, you learn some amount of Sinhala, some amount of Sinhala traditional words, but most of the things you have learned by yourself, from your friends, by using social media. Same story with the computer programming language. Whatever the things we are covering here is very little, maybe like 2% of the entire language, not even 2. There's a lot out there when it comes to this language. So those things you have to do a small self-study. It's like learning actual language. It's like learning actual human language. So when you're learning a programming language, you have to put that effort to become very good with the language. Right? That's the thing, right? So when you learn this, don't expect that you will become an expert in Python just by coming to the lecture, just by doing the activities. No, you have to use external resources, right? You have to go to a website like this and see what else I can do, right? What are these things? How can I do this? How can I do that? Right? So you have to be passionate. That's the thing. Like you can't just sit and listen and learn this, right? So there are things that I still don't know about Python. When I come with some sort of a function, I still go to Google and see what does it do? What does this do? I have to check it, right? So please, when you're learning this, try to like put your own self-studying part as well, right? Continuous learning should be there, right? Individual learning should be there. Anyways, so the normal distribution, this random.normal is one of the most important distributions. I think you are familiar with normal distributions. So it is also called the Gaussian distribution. And if it, give me 1 second, please. So anyways, so use if it fits the probability distribution of many events like IQ scores, heartbeat, etc. So this is like a probability distribution, like you can say it's like a standard probability distribution. So when you want this normal data distribution, what you're going to do is you're going to use this specific function random.normal. And in this random.normal, you can pass 3 parameters. First one is mean, where the peak of the bell exists, right? The peak. So you can see in the diagram that we plot, the mean that we gave was 170. So you can see this is the peak. So you can define where the peak is. Peak. This is the peak, right? So the first parameter that you pass is that peak. It is passed here. Got it? And then the next thing, let me go back to the node, back to the site. The second thing that you pass is the standard deviation, how flat the graph distribution should be, right? So the next value that we passed was again exactly the standard deviation, which was 10. But if you reduce this 10 to 2, let's see what happens to the graph. This is what happens to the graph, right? What is the shortcut to do this? Shift Enter. Okay. Let me change the values a little bit. So if I make this, you can see it changes, the shape changes. So you can see if I make it 0, this is how it looks like, right? If I make it 1, this is how it looks like, right? So it defines, simply it defines how flat it is, right? Basically, how flat the graph distribution should be. Then the size, the shape of the returned array, the shape of the returned array. So I can change the size here. So you can go to the documentation and see a little bit more how it works. So if I change this a little, you can see it changes the shape little by little. You can do a small comparison with it. So this is very good for analysis. You can see the size changes a lot, right? So this is how you make a histogram, right? Or you can actually feed all values by yourself and plot the histogram as well. You have that option. But this is by using the random normal function. You can try this out. You can give different values. I'm not going to give you time for this, but when you are working, you can test it out. I'll share the code, but I'm not going to give you time for this. Right. Let me share the note again. And also, please, if you have any questions, please feel free to ask any. I will clarify the things for you. So this is how it looks like. Let's move to line graphs. This is another type of graph, line graph. A line chart is a graph that connects a series of points by drawing lines, segments between them. These points are ordered in one of their coordinate, usually x coordinate value. Line charts are usually used in identifying the trends in data. The plot function in Python is used to create the line graph. So, I mean, when I show you the graph, I'm pretty sure you are familiar with this, right? Maybe this might be the sales in different seasons in Sri Lanka, maybe how the apparel industry got revenues in different seasons, like in January, this is the amount. So you will see a peak in January, you will see a peak in December, you will see a peak in April, likewise. So in a lot of the seasonal times, you will see a peak, right? So those kind of things you can plot using the line graphs. So let's try to do this. Try to plot this graph by ourselves, which is going to be very simple. We don't have to import the library, so it is already there. So I'm going to say y points equals simply an array. So np.array, or you can simply define the array just without using the numpy. If you are using it, if you are defining it without using numpy, all you have to type is this part in the square brackets, only that, only that. So if you type only this part, removing everything else, it will work. Then you are going to say plot plt.plot. Then you are going to mention the y points. Then you are going to say the color. You can give the color or you can leave the color. If you leave the color, the default color will be taken. plt.show, that's it. So for this, you use the function called plot, right, to plot the graph. So let's run this. And you can see this is how it looks like. If you are not defining the color, it takes the default color, which is going to be blue. Right. So simply what you have to do is you have to mention the y points. That's it. So now I want you to do something. Okay. Try to do this. Okay. Try to do this. You have to add 12 values here. Add 12 numbers. 12 numbers. And then here, again, you have to do additional thing. You have to add X values, January to December month. So you have to say Jan, Feb, March, April, likewise. Then you have to plot a graph. Add 12 numbers here. Then for the X values, you have to give January to December. Try to do this. Check whether it is possible. You have to figure it out, how to give X values. I think you get the idea. Let's assume this is the amount of clothes that they sold in a year, some sort of a XYZ company. Let's say in January, they sold around 500. In February, they sold around 300. Again, in March, they sold around 100. Then again in April, they again sold around 600. Then May, 50. June, 20. July, 30. August, again 60. September, 100. October, 200. November, again 250. December, let's again say they sold around 800. So these are the numbers. These are the numbers. Then I want y coordinates, sorry, x coordinates. That means these values 0.5, those values should be replaced with January, February, March, April, March, April, May, June, likewise. So then you have to define the x points. That means then you have to define the x points. Then you can say in an array, you can say it's Jan, Feb, March, April, May, June, July, August, September, October, November, December. Right? Now you have to pass not just the y points, you have to pass the x points as well. So you have to pass both x points and y points, then you can get the histogram, right? So I'm going to pass the x points as well. Now let's run this. Now you can see, we can see how the clothing industry went from January to December. You can see in January, there's a peak. In April, there's a peak. And then it was incremented when it like becoming close to December. Some people like to go like in December, we can't buy stuff because there's a lot of people. So let's buy on October and November. So you can see there's like a peak. And then there's like an exponential growth. So this is how you can do it. This is how you can do it. And if you want to change the color, you can simply pass the color equals R, then the color will also change like this, right? It looks very nice, right? So let me copy this and paste it to you. You can try this out as well. Here you go. Okay, right. Shall we move to the next one? We shall. Okay. So when it comes to these lines, actually you can change the lines as well. What you can do is you can simply say line style equal dashed. When you say line style equal dashed, the line will become dashed lines. And if you say line style equals dotted, then the lines will become dots. Okay, I will show that to you quickly just for your reference. So if you say the line style equals dotted, and if you run the program, you will see the lines becomes dots, right? And if you say line style equals dashed, then the lines will become dashed. So that is the idea, right? That's how it works. I hope it clicked. Okay. So let me move back to the slides. Then multiple lines in a chart, right? So in a one of these charts, you can have more than one line, right? You have seen these lines in cricket matches as well, like how Sri Lanka went to 300 marks. So you can see like they say they struggle in some points and somehow they go to 300. Then the other team as well, right? Then the other team, you will see it in a different color in the same graph. If they win the match, they will pass our height within 50 overs or before. If they lose, they will go underneath like this. So that's how it works, right? So we can do the same thing here, multiple lines. This is how it works. And this is the code. So what you can do is you can say, same one, you're going to say plot y2 and the same thing will be plotted there. So let me switch to my notebook here. So what I'm going to do is I'm going to copy this y points 1. I'm going to say this is y points 1 and then I'm going to pass this y point 1 here. And then I'm going to make another one, y points 2. And let's say this is a different shop, not the same shop. Let's say this is another competitor. His sales around different months. So let's just change the values a little bit more. So this shop is known to give discounts in off seasons. Okay. So this competitor is known to give discounts in the off seasons, but remove the discounts in the on seasons. Okay. This is that type of a shop. Let's see what happened to this shop now. So let's run this. Now you can see this is the other business, y points to in the blue color. So you can see he does have more sales during the off season. See, because he give a lot of discounts. But during the seasons, the other shop have more business. But again, off seasons, you can see this person have more business. But during the season, again, this person have less sales because his technique is he makes money during the off seasons because he gives a lot of discounts off seasons, but doesn't give any discounts during the season. So different business models, you can see that, right? So this business model is basically earning during the season. This shop owner basically earns during the off season. So you can analyze their tactics. Right? Which is nice. So that's why you draw multiple graphs, multiple plots in a single graph, just for the comparison itself. Okay, I think it clarified the things. Let's move to the next one. So this is how it looks like. Then the scatter plots, right? Very popular type of plot, scatter plot, because usually used in machine learning as well. This scatter plots to find clusters, relationships between variables. So scatter plots show many points plotted in the Cartesian plane, and each point represents the values of two variables. One variable is chosen in the horizontal axis, and another will be in the vertical axis. So simply it is going to be one is going to be represented in the x-axis, and the other one is going to be represented in the y-axis. So the simple scatter plot is created using the scatter function. So the function is going to be scatter, right? So just as usual, it is going to be inside here, we will pass different types of parameters, and these parameters will change how the scatter will behave. Okay, let's move to the next slide. Right. So now you can see, as we mentioned, we have two axes. One is going to be x and the other one is going to be y. So for the X, we have some set of values, and for Y, we have some set of values. And we have the plot. Inside the plot dot scatter, we pass the X and Y, and we say show, right? So if you do something like this, this is how it's going to look like. You can see there are some scatters very close to each other. We can cluster them, and then we can figure out relationships, right? We can figure out relationships. So let's try this out as well. So let me try this in my Jupyter notebook. So we are simply coming to the end of the lecture. So please don't leave the lecture, just stay the last few minutes as well. Then you can cover the entire lecture. I can see like there was like 5 or 6 students already left. Don't leave, because just try to participate in the lecture. Listening is will give you some sort of idea. And since it is not going to be a very long lecture, just please wait and listen and try to do these things by yourself, because otherwise you will struggle in your exams. Right. So I am going to create a small data set just to get an idea with this. Then I'll give the y-axis. Y-axis should be the same size as it is. For every x value, there should be a y value. So I have to use the same array. You can simply use the array like this, as I told you before, or you can use the NumPy array. I don't mind. I really don't mind. This is good practice. Bear with me. Let me quickly type this up. Okay, looks fine. Then I'm going to say plt dot scatter x comma y. Then plt dot show. Right. Let me run this, and you can see the relationships. So you can see there's like a cluster here. Here it's very close to each other. Likewise. So there's another code here in your slides where you draw 2 plots in same figure. So this is, there's a message, let me see. Yes, I will give you a confirmation. Okay, sure. So here, import matplotlib. And now you can see day 1, the age and speed of 13 cars. So the idea is very simple. Here in the day, this data was collected in 2 days. In the day 1, the age and speed of 13 cars, right? So the age of the car, the speed of the car, right? And day 2, the age and speed of 15 cars. You can either change this to age or quantity. I don't mind. Then you can see 5, 99, 7, 86, likewise. You can see like new cars when the age is 5, they are very fast. There are some old cars that is very fast. There are different. So then you have another one, another data set where it was collected from 15 cars in the day 2. So you have 2 data sets. Now what you're going to do is you're going to plot these 2 data sets in the same plot. So what you're going to do is you're going to say plot scatter x comma y. So this will be plotted there. Then again, after accessing this data set, you're going to say plot dot scatter x comma y. Again, the same plot will be used. So when you say plot show, both will be there. So I will show you how this works, because this is very interesting thing. Let me show you something here. This actually is very interesting because it actually depends on where you type the plot.show, okay? Because, give me 1 second. So this is the day 1 data that I collected. Okay. And then I will paste the day 2 data that I collected. So this is the day 2 data. Okay. Right. So now, if I say plot.show, there's a problem, I think, non-printable character. Yeah, here. Is that the space? In syntax error, I forgot to close this. Okay, my bad. Right. So now you can see there are two colors. One is blue, one is orange. And so the first one, the blue color one is for this, and the orange color one is for this. But if you put plot show here, what will happen? If you do this, you can see there will be 2 separate plots. You can see it depends on where you put the plot.show, right? So if you put plot.show here, this plot will be generated for this, and this plot will be generated for this, because you have added 2. The programming language is smart enough to figure out to which plot, which data set should go. But if you only put one plot.show in the end, that means both these data sets will be represented in the single plane. So if I run it like this, now you can see this is the idea. So there's so let's assume there's like in machine learning we have something called the hypothesis. Then let's assume this is the hypothesis that we have. From here we can figure out like the clusters and everything. So you don't have to worry about those things. But yeah, in IT we use this a lot. In computer science we use this a lot to find relationships between different things. For an example, diabetic patients and their sugar levels. Or we can say diabetic patient locations and their sugar levels. So depending on the city, we can figure out whether there are clusters. In Colombo, do we have clusters of people that have diabetic? Likewise, like we can find a lot of things using these types of graphs. These are very frequently used graphs in lots of domains, including in the financial and the commerce, business, likewise. Right. So that is the last type of graph that I want to explain. Then let's do a quick activity with a big data set. Then we can call it a day, right? I'll share you the data set and I'll show you how to use it. Give me 1 second. Okay, I'm going to share a CSV file, which is going to be a Excel file with you. So we are going to use this Excel file to do our work. Okay. Right. I think you all got it. So what I'm going to do is I'm going to save this Excel file in my desktop. Okay, so I will share this in my desktop because then it is going to be right next to my Python folder. That's all. Okay. So what you have to do is first thing first, if your Jupyter Notebook files in desktop, also save the CSV file right next to it. So it's easy for you to access. So in my desktop, I have my charts.Jupyter Notebook and also the Byte Bias CSV file. Okay. So the next thing I'm going to do is I'm going to create a new notebook with the name bike. Right. We'll remove this one from here for now. So quickly download it. I'll give you like 2 minutes. Quickly download it and create a new notebook with the name bike and save that CSV file right next to it. Okay, desktop पे केना ये file लेकर तीन मेरा desktop पे केम save करा. Placing वेडी तमा desktop पे के save करना. Right. Now let's start working with this file. First of all, let me show you the file first, how it looks. Then you can get an idea what are we working with here. Okay. So let me go back to the home. So this is the CSV file. So if you open this, you can see it's just a table with different information. Like this is about people who bought bikes, right? So married, gender, income, children, likewise, okay? The occupation, everything is here. All the information is here. So it's a big data set. We have around, let's see, we have 1,000 data points. Okay, we have 1,000 records about people who bought bikes. Okay, so now what we're going to do is we are going to analyze this data set. To analyze it, first thing first, we have to import the required libraries. Okay, so I'm going to import bunch of libraries. First thing, the familiar ones, import pandas as PD. Then whenever I want to use the pandas, I'm going to say PD. That's it. Then import NumPy as NP. Then import, I'm going to use Seaborn as well. So you will get the chance to use it. Seaborn as SNS. Then import matplotlib dot py plot as plt. Right, so let's first run this. Pandas is not found. That means we have to install pandas because I think I didn't install pandas. So let's run that command first. I'm going to remove everything from here and I'm going to run the command pip install pandas and I'm going to run this. So it is running, you can see. This might take some time depending on your internet connection. So with this command, what we do is we are downloading and installing the pandas library. You can see the icon changed here. It is loading. So that means it is downloading and it is installing. Might have to give it some time. Let's give it some time. Like might take like 2 minutes. We'll see. Still working? Right. So I'm getting a message, yes. Installing. Okay, successfully installed pandas. Okay. Now my installation is successful. So I'm going to remove this and then I'm going to paste whatever the things and now I'm going to run it. Right, no errors. That means, okay, there's another error. Seaborn, because Seaborn is also not there. So I have to install pip install Seaborn. Same story, run it. Might take some time. You may need to restart. Okay, I don't need to. Collecting Seaborn. Correct. It is successfully installed here. So now if I run the command, no error should be there. Yes, no errors at all. That means I'm free to use the features of all these libraries. So I'm going to say data equals, first thing what I want to do is I want to capture all the data in the Excel sheets. So I'm going to say PD, that means pandas dot read CSV. Read CSV is a built-in function because we have a CSV right next to my file. So the name is bike underscore by a CSV. So I'm going to copy this name and then I'm going to paste it here. Okay. Then I'm going to run the command. Then I'm going to say data. Now you can see when I say data, it took all the information from that comma separated file and then displayed it here. When I just call the variable data, it told me there's 1,000 rows with 13 columns. All the information is there. So this is one of the functions that you can use to read the CSV file, which is very nice. You can see the first 4 and also the last 5 records in the data set, right? And if your file is in a different location, then you have to mention the location like this. I'll show you how to do it as well. So you have to go to the file location. So this is the file location. You have to go to properties. From properties, you can find the location like this. See? Then you have to copy this location to here like this and then say bike buyers. Then and also I think you have to use double lines here, as I remember, not single lines. This line should be double lines. That's a thing in Python like this. Then it will work. So now you can see I access the file using the file location. So you find the location from here, right? And then you copy this location and to the end, you paste the file name and the file extension .csv, then it will capture it, okay? After that, now you have access to this data, right? Then what you can do is you can do different kind of analysis. So for an example, if you say data.head 10, what does this do, right? This will only print the first 10 values in your data set. So when you say 20, it will print the first 20 values. See? And if you do something like this, what will happen? I'm curious. Yes, it will show you the last 10 as well. See, now it will show you 10, right? Likewise, you can play around with this. You can play around with this. Then if you say tail, this is the head, right? So if you say tail 10, that means the last 10 will be printed. See, 990 up to 999. So the last 10 values will be printed like that. So I will keep the head in a separate one, and I will keep the tail in a separate one. So this is what you call proper data analysis using Python. So now you can see this is what we targeted throughout the module, right? We learn the basics, we learn loops, we learn the different kind of things, but this is the final thing that you should be able to overcome, right? This is the analysis part. Okay, so this is the tail. Then what we can do is, you can say, we can ask to describe the data. So when we say data dot describe and run the program, it will describe everything about the data, right? Once you run this command, right? Once you run this command, can you see the amount of information we get about this data set? There's a lots of information. You can see I only ran the command data.describe. It will give me the count, the mean, the standard deviation of the data set, right? The amount of information, the minimum, the first quarter, the Q1, the Q2, the Q3, the max, everything will be here. All the information will be just one command, data describe. You get everything, right? Then data info, from the data info, they will give you the information about the data, like the ID, the marital status, gender, just describe the data itself. See, data types is also mentioned. The data columns, data rows, the unique data, right? Genders have 2 unique values because it's male and female. Likewise, you can, if you are not like, if you can't understand whatever these kind of things, you can just use some sort of a online tool, like you can use a ChatGPT or something and ask them to explain it to you, like explain me what is this output means. Then you can get idea. I told you, you have to do a self-study, you have to do a self-analysis, then you can get a very good idea. So you can see there's lots and lots of information here. So you can also see there's charts, box plots are also being developed for it as well to understand outliers. So all this information came from a single function. That is the surprising part. We ran data.describe and voila, we have all these things. And we have all these things. All this information, right? Okay. So let's run the other things, data.info, right? This will give you more information about the data. I'll just quickly go through this. So since I told you what are the things we can get, data.dtypes. Here's a problem. Oh no, you don't need the commas for this. Like this, you can get the data types from here. Then you can get the shape of the data. So like data.shape. Then I will run the commands. Then eventually I will give you the recording. And what you can do is you can retry these things. Okay, you can give, like you can try this again later. No attribute column. There's an error here. I will debug this later. There should be an N here, I think. Yeah. CULUMNS. Yes, like this. Right. And then data dot column to list. So all these columns will be converted into a list. That is the idea. See, now you can see it is inside a list. I think you know what's a Python list is. You have a square bracket here, you have a square bracket here. The same thing was now inside a list. That is the idea. So there's lots of commands that you can run. For an example, if you want to find the unique values, you can just type data.unique. Then you can get the unique values, QU data, it should be N unique. Okay. Yeah. So these are the unique values. You can see the marital status, either it could be married or unmarried. So because of that, we have only 2 unique values. The gender, we have 2 unique values. It could be either male or it could be female. For income, there are 16 unique values. That means there are different 16 types of incomes. Then children, maybe 1, 2, 3, 4, 5, 6. Education types, there are 5 education types. Occupations, there are 5 different occupations. Caste, there are different castes, likewise. You can see. And also, if you want to find what are the unique gender types, what you can do is you can type data inside square brackets. You are going to say, I want to see the gender. And you are going to say unique. Then it will give you the number as 2. Then if you want to see the data itself, then you are going to remove this N. N means the number. If you just say unique, it will give you the values. See, male, female. Likewise, I mean, you can play around a lot with data. I will do this again in a different session. I will try to do another online session just to analyze the data. But today I will give you a lot of commands that you can use. I'm not going to explain them a lot, but what I'm going to do is I'm going to give you a lot of commands. So once you are watching the recording, try to use the commands and see what information you can get. Okay. Then I will explain this information in a different, different lecture, online lecture. Okay. So we are not going to have another physical lecture as I remember. So because of that, I will do this entire thing one more time in online lecture, but today I will give you the information. So you can do a box plot for the income like this, right? And if you want to drop the duplicate data, for an example, in a data set, you might have the same data multiple times. It could happen, right? That's what you call data cleaning. You have to remove the duplicate data. So if you want to remove the duplicate data, this is the command that you write. Data equals data drop duplicate, drop duplicates. Then when you run this, all the duplicates will be removed. Then if you run the data, if you print the data one more time, all the duplicates will be gone. So in this case, we still have 1000 rows because there were no duplicate data. But if there were duplicate data, the number of rows will be changed. And if you want to count the data after dropping it, you can do this as well, data.count. Then it will count everything. The number of IDs are 1000. Number of marital statuses are 990. Likewise, you can count everything. Okay. So I will share you this Jupyter notebook, right? So what you have to do is basically you have to practice these commands by yourself, right? So as I told you, you can draw box plots, you can count, you can uniquely identify values, everything inside Jupyter notebook. Okay, so what I'm going to do is I'm going to share you this notebook with all the commands, and I will share you the previous notebook as well. So what you have to do is you have to practice this by yourself. You will have like another week to practice it. So practice this first, and in the next week, I will select a very simple data set and analyze it. So you can get an idea. Okay, so we can stop the session. So I finished it on time. So if you have any questions, you can stay on the session and ask the questions. I will give you the recording. So go through the recording one more time, practice everything, and then we will discuss it. Do we have end exam through online or paper-based? It is going to be a paper-based one. It is going to be practical. So you have to come to the examination hall. We will give you the paper and you have to give answers in the Jupyter notebook. We will do a mock examination for the final. Don't worry. We will do a mock examination. That means a practice examination for the final. So don't worry. So go through the recording and practice this by yourself. I will see you in the next lecture. Thank you.